Good morning, and welcome to our session on JavaScript applications for the enterprise, building for production. I'm Randy Jones, and I'll be joined today by Jackie Roberts. We work in Esri's professional service division, and we help clients both with custom applications and widgets, and helping them to design and implement their enterprise architectures. Today we'll be focusing on taking our JavaScript applications and getting them ready for production. We will be talking mainly about building that application to reduce the number of calls between a client and the server, as well as reducing the amount of data that is transmitted across the wire in the process as well. But before we dive into that aspect of getting an application ready for production, we have a few things that are always and forever best practices for us. Whenever we set up our web server, we should ensure that gzip is available in transmitting across the wire. Gzip will allow the requests that come between our web application and the client machine to be compressed in such a way that it reduces the size of things across the wire. The web browsers are very efficient at decompressing this data, and it helps you save cost if you are charged by data coming in or out of your environment. The next thing is thinking about our image sizes. It doesn't help us if our images are 600 by 600, but we're only displaying them on the screen at 60 by 60. So make sure that you're using appropriately sized images. You can use an image editor, or depending on the type of image, even Microsoft Paint to resize those images. Next is spriting. Spriting is a technique where we can take images that we might be downloading separately and combining them together into a single image, and then use CSS to display just the part of the larger image that we want. This is a common technique used for button images. If the image is larger, we may not gain the efficiencies by combining everything together. So while it helps us to reduce the number of calls to the server, reutilize more images from our cache, there is not a reason to combine every single image from your website together. And finally, thinking about our application starting up, we want to think about blocking elements. Things like script tags and CSS style files will block our page from rendering as they load if those script includes are at the top of our web page. So one technique to use if you're building a custom JavaScript API application is to do those includes near the bottom of the page as much as possible, and using straight inline CSS and HTML, present the user with an initial screen that is pleasing to let them know that the application is loading and doing what it's supposed to be doing while you begin to start loading the JavaScript API and other libraries that you might be utilizing within your application. Next, let's talk about your specific application and analyzing it for production. If you have a public URL with your application published, you can utilize PageSpeed Insights, which is a tool provided by Google that will do lots of analysis on your page. It might tell you that your images are too large, that you should consider moving some of your styles to inline to present the first draw within your page. So it can be very helpful in starting to improve the performance of your page. Google Lighthouse is a web developer tool built into Google Chrome. It's a great tool. It's similar to Google Page Speed Insights, but it has a little more of a security slant to it as well. So using these tools together can help you to start to tweak your application and the user experience that is going on. Next, let's talk about your web server. Common web servers might be Apache or IIS, HTTPD server provided by Apache. All of these are commonly used front ends for Esri applications. And using this GitHub repository is a great way to set up one of these and look at commonly best practices for enabling gzip, having all the performance tuning in our applications as well. One new thing this year that we want to point out is I really want to encourage you to enable HTTP 2 as a part of your web server. The reason that HTTP 2 provides us improved performance is that the binary protocol, we get benefits of things of the protocol, even without more advanced features of it with server push. But I do want to highlight that you should really only use this with HTTPS only. Depending on your web server, IIS, for instance, will be enabled by default. In Apache HTTPD, you'll have HTTP 2 available since an early version of 2.4. Tomcat as well can support HTTP 2 if you're only using that as your web server. Make note that with the recent Ghost Cat vulnerabilities, that you should pay attention to your Tomcat and Apache versions, especially if you're using Apache with the mod AJP proxy. And if you're not using AJP, be sure to disable it. Here's an example of how easy it can be to enable HTTP 2 within Apache HTTPD server. It's really as simple as loading the modules and then putting the protocols directive within our HTTPS virtual host. Next, Jackie will begin to tell us about building.
Thanks for the introduction, Randy. For everyone, I'm Jackie Roberts. I'm a front-end web developer within professional services at Esri. So I'm going to be talking about build tools. If you build it, they will come. Moving your application to production really means making it production ready by building things out so that you can minimize and obfuscate your JavaScript files and flatten them into hopefully a single file. This is in contrast to when we develop, we have multiple JavaScript files, kind of self-contained, separated, abstracted component style files. And then when we take them and build them to be flattened out into one file, this drastically improves the performance by limiting the network requests. So first up, let's look at how we can incorporate a build tool with applications or code bases that we're already working with. How do we get those production ready? In the past, at this talk, I know we've shown a bit more on the Dojo build. So this tooling is offered by the Dojo build is based on its intertwined nature with the ArcGIS API. It is fairly heavy on your CPU. It's not something that you're typically running on the day or as you develop. It's more so at the end life cycle of your app before you go to host it in your production environment. One downside is that it's not super easy to hook up with modern frameworks and libraries. So if you're using something like React or Ember, Angular, what have you, there might be other tooling options that you want to explore. That being said, it's still a very solid option. It does reduce the network requests. It does do its job at building out your application. And it's good for any projects that are using the ArcGIS API. So given where we are today, I'm not going to focus too much on demoing code built by the Dojo tool builder. But what I will do is I'll take a little more time to look at things like Webpack and how to configure your application with the ArcGIS API and build that out. So Webpack as a build tool can bundle up your project into a single flattened file and really takes advantage of dynamically loading items as needed. So we'll take a look at a legacy application that uses that uses the ArcGIS Web Pack plugin to integrate the ArcGIS API with Webpack to build it out. This is specifically an option for this for this legacy application because it's using the ArcGIS API at a version of 4.7 or higher. So real quick, just take a look at this. Here's our enterprise application. May look similar or familiar from last year. It is, web mapping application. You can hide transportation, hide the assets. And here it is. So going back to our PowerPoint presentation, let's take a look at some of these dependencies that we'll need to configure in our app. So in your package.json, we're going to use npm install to get a couple of things in there. The ArcGIS Web Pack plugin is what gets the app working with Dojo and allows for the app to work with the ArcGIS JS API. So you can see that down towards the bottom. We do have a couple other typical dependencies that we've loaded in here. It will vary project by project, but we have, the clean Webpack plugin to clean any dist folder after you run your build. So if you run a new build, it's fresh. We have the copy Webpack plugin dev tooling to copy over static files like images. We also have the Webpack dev server, which allows us to run in development mode. So in contrast to the Dojo builder, where it's super heavy and kludgy, we can have this Webpack dev server and configure it so that it's doing this live reload-esque functionality. So as you're developing, it's rebuilding it. It doesn't flatten it out as much as if this were the Webpack for production, but it helps as you develop along to kind of see your changes in real time. So let's take a look at the next slide, just some legacy app integration tips and tricks. So these are some things we found when you are trying to integrate Webpack into your application. Want to really note here that relative paths are easier. Defaults to be referenced from the entry point root. So instead of something like require build project / build project, it'll become require at the root level or entry point of your application / build project. And then if you're using digit templates or Dojo text, we have some workarounds to deal with these old school templated widgets. There is the normal module replacement plugin to replace it so that Webpack can handle it, because the Webpack and Dojo text plugins are using a similar syntax that'll conflict otherwise. And then we also have, for static config files, the use copy Webpack plugin. So let me bring up VS Code. And here we go. So we've seen here in our package.json some of these dev dependencies. We have a couple others in there right now for our testing talk. But you have the dependency down here for the ArcGIS Webpack plugin. Up top, you'll see we have a couple of scripts. Really starting with start. Again, we have it configured for the purpose of this demo to be the serve dev, so it's using that Webpack dev server. And then you have a build. Once you run that, it's going to spit everything out into your dist folder. Then if we take a look at the Webpack config.js file, that ArcGIS plugin that we installed, you can see starting off right there. Then we have our typical ones, the clean Webpack plugin, mini CSS extract, Uglify JS plugin, HTML Webpack plugin, copy Webpack plugin. So we go ahead and we start out with where our entry point is for our application. And then continuing on down below, you'll see that we have our output, what's going to be in that dist folder. We start with the Uglify.js plugin. You have a couple options that you can configure based on your own personal preferences. And then we're really going to go in and start using things like clean the Webpack plugin. Go ahead and remove anything that was in the dist folder. Copy the Webpack plugin to grab data or images over. Here, this is where we're dealing with this old school templated widgets, and we're just doing that normal module replacement plugin to replace that Dojo text with the raw loader. We have our ArcGIS plugin, our HTML Webpack plugin, mini CSS extract plugin, and that's pretty much it for that. So if we take a look at this app now, it's been configured with Webpack. I open up DevTools. We'll just take a look to the side. When I reload this, you can really see right here, things broken down, uglified, minified. And what you want to start paying attention to is, this is a simple sample project, but when we're talking about these production level applications, limiting the number of these requests and seeing how fast the DOM content loads and everything overall loads, you start to see big performance improvements there. All right, so then let's take it back over to PowerPoint. And that's integrating a build tool like Webpack into a legacy application. But now, what about if we have the opportunity to start from scratch? And setting up Webpack in an existing project, it's often a heavy lift. There's a lot of moments where I feel like we find ourselves banging our heads against the table. So one beautiful aspect of creating an application using a command line interface is that they often provide the boilerplate to get your app up and running right away. And it comes with scripts referenced in the package.json where the build process is already baked in for you. So you don't have to do too much heavy lifting or setup. If you have the opportunity to start on a new project, use a CLI. Last year, George showed you how you can configure an app with the ArcGIS JS CLI. This year, I'll review that option and point you to some resources for the ArcGIS JS CLI, but then I'll dive a little deeper into another alternative using the React Framework CLI Create React App in conjunction with the Esri loader and getting that set up for a build. So again, once you've npm installed your ArcGIS JS CLI, it's as simple as running ArcGIS create and whatever the name of your application is. It does take a while to go through and build out that boilerplate code. Once you do, you will pretty much be ready, set to go to start building out your application. I do have a resource here for you to take a look at. Let me switch over. So this is referenced in the slide. You can see a demo app right here with this, and this is kind of what George went into last year. It's showing you how to get the ArcGIS API into this and using the ArcGIS Webpack plugin right there. So very similar to what I was showing you with the enterprise legacy application, these typical plugins. You can clone this repo, download it, and start your own application that way. All right, back to the PowerPoint slide. So there's several CLIs to choose from based on your framework of choice: Ember, Vue, Angular, React, etc. Some are easier to configure with Webpack than others. Some you have to eject the application, which is typically one of those processes that you can't take back, but once you do eject the application, it exposes the Webpack configuration that's been like bundled up and kind of internally nested inside, taking care of this build script on your behalf. But so, because some are easier to configure with Webpack than others, what do we do with the ones who aren't as easy to figure out on our own? And so we have the Esri loader as an option to integrate the ArcGIS API into your web application. Right here, sorry, I meant to switch over. I'll go ahead and show you. I've basically just used the Create React app. I've installed that and created my app, Build Esri Loader. Then I've gone ahead and gone into that directory. You'll see that it has the boilerplate there for me, the source, the public, my package, my node modules. And then the last thing I need to do to get this set up is go through the npm install save Esri Loader. We have a couple references here for you on ArcGIS and React, as well as the Esri Loader. So let's take a look at this right here. I'll open up VS Code. So here we have it, build Esri Loader. We're gonna have our build file, our node modules, we have our public folder, and then our source. So we have a lot of boilerplate that comes in. Your index.js with your app.js. And then I've gone ahead and built out a web map view component to just demonstrate this. So first, let's take a look at the package.json. Just by installing and creating a React app with this CLI, I go ahead and get a ton of dependencies and libraries already configured within here. And one of the beautiful things about that is this build. So once I've built out my application, I can run npm run build and then take whatever's in that static folder and host it in whichever way I decide to serve out that web application. So, and that's all I have to do. I don't have to configure Webpack, so it's a very, very easy lift. So I've gone ahead and started this, and we'll see right here. This right here is pre-build. So if I go and close this out, looking at this right here, I just npm start my application. I have a typical web map with a dot density layer. When it loads, you can see right here, this is, a very, very simple demo application. 31 requests, a little under 3 megabytes transferred, finished in about 3.5 seconds. It loaded in 1.72 seconds. So that's just npm start as I'm developing. If I go ahead and I run the build and host that, we can take a look at this right here. A little fewer requests. It finished in 3.17 seconds, and then it loaded in just about a second. So again, these numbers right down here may not be as glaringly obviously huge wins, but consider that this is increasing the efficiency by about 30 to 50% in some cases, and it's for a simple demo app. So when we're talking about production-ready apps that we're hosting and serving up, this becomes a huge win when there's a lot more going on and we want to flatten out all of these files and more dynamically reference them on an as-needed basis. So if I went ahead and took a look at this right here, just for comparison's sake, you can see how it's been flattened out and everything's included in there, removing white space, replacing with variable names that aren't very descriptive, but minifying and obfuscating that code. And then if I went back over here, pre-build, and took a look at that, you can see it's all built out. When we start, it's just not as efficient, not as nicely flattened and condensed. So going back over to my PowerPoint. This wraps up how to get your application, whether it's a legacy application configured with modern build toolkits or starting from scratch. I'm going to go ahead and bring up this in VS Code real quick so we can see how we incorporated Esri Loader. So again, building out with this Create React App CLI and installing the Esri Loader. For my component, what I went ahead and did in this web map view, I import React, but then I import load modules from Esri Loader at the top of this file. And you can do this using hooks or classes. I have an example of a React class. Once my component did mount, I can load the modules that I need. So if I'm going to be doing a map view, this density renderer, and I set my CSS, based on your preference. I'm just referencing the dark theme here. That's how I can lazy load those modules in using the Esri loader. So just wanted to point that out real quick. So now that I've done that, I'm going to go back to the PowerPoint. And I will turn it over to Randy so that he can talk about what do we do when it's Web AppBuilder and we need to build for production. Thank you.
Thanks, Jackie. But what about Web AppBuilder? Web AppBuilder has become a popular framework for developers to use to get lots of great functionality out of the box and be able to extend it, adding their own functionality. Well, for a number of years now, we've been working on the Esri Web build. And it's exciting to announce that we now support the 2.15 version with the Esri Web build. Now you might notice that the home of the build tool has moved under the Esri organization on GitHub. You can also simply just do npm install. I suggest adding the -g flag to deploy it globally. Esri Web build. So the first thing I want to show you with regards to the Esri Web build is what it looks like for our developer edition. I've come in and created a test application, and I've added a few tools to it, but it's nothing fancy right now. But I want to do is I've downloaded the application and I'm now hosting it on my web server. What we can see here is there's over 450 requests made, about 10 megabytes of resources, and it took about 1.8 seconds to load and about half a second for the download. So what I want to show you now is how easy it is for me to go ahead and build this application. So I've navigated into my Web AppBuilder directory here. We can see my application is here. We can see all the widgets and the theme for the application. And we can see the configs for the widgets that have been added here. I added the about and the add data dialogues to it. So let's go ahead and install the Web AppBuilder build. So npm install -g Esri Web build. We can see that it's now installed, and since it's installed, I can simply do Esri Web build. Now, I'm going to do this against the folder that's within the Web AppBuilder build, but you could certainly do it after downloading the application first from the Web AppBuilder. So we're going to go ahead and start running this. And what this will do is this will start the build, and it will create a dist directory for you next to your application folder. So we can see the dist directory has started being created. A copy of the application is put in it because we don't want to disturb the original version of the application. And we can see that there's lots of things being copied in here. This is the JavaScript API and all of its dependencies. Because remember, unlike what Jackie showed you with Webpack, Web AppBuilder is still built on the 3x version of the API and doesn't support the Webpack model. So under the hood, this is going to continue to run the Dojo build. It's installing all the dependencies via Bower, and is now going through the process of obfuscating our code, pulling all the dependencies that we need together so that we have fewer resources needed for our application. Now, you want to understand that this is a hefty process and you should not run this process on production servers. So I've gone ahead and canceled the process because I took the time and built the application before recording this. And we can come in here and we can look at the build output within my dist folder. We can see that it's created a zip file and it creates a folder to go along with it. I've copied that folder over to my web server, and we can see that here. The application loads and performs extremely fast for us. And so we can see that while there is more resources loading, we've cut the number of requests in almost a quarter. So by balancing the size of our resources with the number of requests being loaded, we get a much better response time for the user. Earlier, when we talked about looking at our web servers, we talked about a number of things like protocols and gzip. So I just wanted to show you a couple of examples of that. We can see over here in our first test run, I made sure to be using HTTP 1.1 without gzip compression. As we go down the line here, I've added gzip compression to this. So if we come back here and look at the top, we can see now that let's take the env.js file as an example. It's 4.9 kilobytes here. If we go look at the first one, it's 15.3. So we've greatly reduced that time of the megabytes transferred across the wire. The next thing that we can look at is utilizing HTTP2 and that binary protocol. Adding that into the mix, we see that again, we have the great benefits of the gzip compression, and we can see that it is now using the HTTP2 protocol, and we can see that the megabytes transferred across the wire is even slightly less, and we end up with 1 or 2 fewer requests. And then finally, when we're combining the goodness of the build with the protocol and gzip, we can see that our megabytes transferred across the wire is still a good small number. Our request is a great small number, and our application loads very fast and gives us a good user experience. One of the things that happens after this build is all of your files like Dojo, CSS, the Dojo.js file, and the supporting files for the JavaScript API, like the vector tile layer implementation, are all local. In these other test builds where I had exported the file, we're reaching out to ArcGIS Online. You can even see when we reach out to ArcGIS Online, it's already using the HTTP2 protocol. So now that I have my Web AppBuilder project from the Developer Edition that I can easily deploy, what about custom widgets that I've developed? Well, we have a suggestion there for you to look at using the Yeoman generator. The Yeoman generator is a great way to scaffold out a project that will give you widgets for you to develop in, and it even comes with everything you need to automatically copy those widgets into your Web App Builder Developer Edition project. That way, as you're coding in your repository, you can see live with refreshes the output of your work. This separates your custom code from the Web App Developer Edition code, making updating to more recent versions of the Web App Builder easy. The other thing that you can consider doing is if you have widgets that you're using in multiple projects, you can separate your widgets from your Web App Builder configuration. This way, you get the goodness of widgets that can be included into multiple projects and your configuration for a specific application, both being separate from the Web App Builder core code, thus allowing the upgrades to go smoothly. We'll show you what this looks like in a single project. You can use your configuration project and pull in widgets as remotes into it, or you can just have one project that has both your configuration and your widgets in it. You just need to go with the simplest solution based on your overall needs. So we have the Web App Builder. We can build the Web App Builder, and we're separating our code from the Web App Builder code itself to help us be able to modify the Web App Builder Dev Edition version easily. So now that we have this building and we have the build, what we want to do is we want to integrate this into a pipeline to help us get this build into production. We do this with continuous integration. It helps us deploy things faster, both to our QA environment and to our operational environment. There's many options out there. I'm showing icons up here from Travis CI, Jenkins, Hudson, and Circle CI. Many of the platforms these days for source control have these sorts of tools included in them as well. So before we get into a demo of how this looks and works, this is what the pipeline will look like. As I mentioned before, our configuration project is the center of things. And we have, my choice is that I have a widget project being pulled in as a sub-module to my config. Then what we'll do is we'll use a Web App Builder application with every single widget and theme in it, and I'll show you how to build that. And what we'll do is we'll pull our config project and configure it to tell it what Web App Builder app to use as its template app. It will bring all those together, it will build the application and deploy it for us. So what does this look like for us? This is the Jenkins interface. It's very bare bones at this point. You can see that I have a number of projects here. We have both the Dojo and the Web App project of our enterprise sample application running and building and deploying. And we have our Web App Builder project here. When I configure a project within Jenkins, it asks me where I want to pull it. And so for this case, I have it pointing to my Git repository for my Web App Builder config project. And I'm telling it that I want it to pull from the master branch. So what this is going to run off of is a Jenkins file. If we look at a Jenkins file to see what it looks like, we can see here that it puts steps together for us that match the stages that we see in Jenkins. The first thing that the pipeline will do before it begins to execute is check out the Git repository. Then we have a build step. Here's where we're doing three things. We're copying over the template application into our project. Secondly, we're copying our custom widgets and our application's config into the app directory along with the template application. Then we're just going to run an npm install and an npm run build. npm run build, in this case, we can see it's just running the Esri Web AppBuilder build against the app folder that we copied all of our contents into. Upon the success of that build, we're going to copy the application and stash it. This is a feature of Jenkins where if the cluster of Jenkins servers is more complex, a different server might actually run the next stage. In my case, I only have a single server, but I'm showing the more complex configuration. Next, we'll bring back our stashed application, and we're using Grunt in this case, which is a task runner, to deploy our application. Looking at our Grunt file, whenever we run the deploy command, we run just a Tomcat redeploy. We see that our Tomcat redeploy task has all the information needed to deploy it to our Tomcat server. This step could easily be replaced with a copy to a folder in Apache or IIS, or deployed to another server, like WebLogic or another more complex web server. And finally here, I have a milestone. What this milestone does is this blocks the deployment of my application, waiting for me to respond. And as you can see here, I'm doing a second deploy, but I'm passing in the port of a different web server. So here, we're simulating the move of applications to our development environment for our QA, and then onto our production. If we look at our project, we can see those steps nicely laid out for us, and we can see a project right now that's paused, waiting to be deployed to production. During the running of this project, we can come in to any one of our past tasks and see precisely what's been done. Here you can see the Web AppBuilder build is running, and at this point it's actually cleaning up itself. We see the end of the build. We can start to see the rest of the pipeline run. So what does it look like to build the Web AppBuilder template application? Here, I've created another application. Now we're in application 3 within our Web AppBuilder Developer Edition. And I just created it with one theme, and I didn't even bother to add any widgets to it. Once we have this laid down, what we're going to do is we're going to go back up in the Web AppBuilder Dev Edition. We're going to come over to the client folder in the STE map folder, and I'm going to copy the themes and the widgets folder from here and put them back into my folder here, overriding the themes and widgets folders here. Once I've done that, you can see that all of the possible Web AppBuilder widgets and themes are now within the folder. When I run my Jenkins job, we saw in its configuration that we have a parameter that we're using telling it where the Web AppBuilder template app is located. And the Jenkins file utilizes that parameter as its source location to copy the application from. So now, if we look at my parameter right now, I'm pointing at the 2.11 version of the API. Because I've separated my core code and configuration from the Web AppBuilder core, I can easily update this to point at a new application and begin running a new build. This build will, once it's successful, will automatically deploy to my QA server for me to validate before I continue on to production. For previous jobs, I can decide whether I want to proceed with them or whether I want to abort them. So thank you for watching. We hope that you can now utilize techniques for taking your custom and Web AppBuilder applications and building them for production use. Remember the resources that we've talked about today. Last year's Developer Summit talk has lots of valuable information. We go into greater detail about separating your Web AppBuilder code from the core Web AppBuilder. Don't forget about Google Lighthouse and insights in looking at how your application is running and where you can improve upon it. Remember the Webpack plugin and the Esri Web AppBuilder build. We also have the accompanying related talk to this. We also have the accompanying talk to this about test-driven development and how to incorporate it within your JavaScript applications. Jackie and I thank you for watching. Let us know if you have any issues. You can tweet at us or let us know in the comments.